Hi, in this video we're going to learn about the total probability rule, and we're going to look at an example of product failure that's due to chip contamination. So in the table I've tried to summarize the information we know. We have a product that's going to be made with chips, and the chips were either exposed to high level or not high level of contamination when they were manufactured. So the chips that were subjected to high levels of contamination, let's say those are the event H, and the chips that were not exposed to high levels of contamination, let's label that H complement. So if our sample space is of all the chips that we manufactured at this company, the chips were either subjected to high contamination levels or not high contamination levels. So S is broken up into these two mutually exclusive events. High contamination levels, 20% of the chips, and not high contamination levels, 80% of the chips. Okay, so what's going to happen next is we make a product. And I'm just going to draw over here our product for today. So here's our product. And it's either manufactured with chips that were exposed to high levels of contamination or not high levels of contamination. And what happens is there's different levels of probability of failure for the product dependent on the chips being manufactured or exposed to high or not high levels of contamination. So notice if the chips were exposed to high levels of contamination, the probability of product failure is 10%. And the chips were not exposed to high levels of contamination, the probability of failure is much lower in this case. In fact, let's write that out right now. The probability of product failure given the chips were exposed to high levels of contamination is 0.10, and the probability of failure given the chips were not exposed to high levels of contamination is 0.005. So if F, let's go ahead and let F be the event of failure. This event spans both H and H complement. And let's go ahead and draw this in just a tiny bit in H complement. So this is the event of failure. So failure can occur both in H and H complement. And these are two mutually exclusive. Failure happening in H and failure happening in H complement are two mutually exclusive events. Okay, let's go back to the big problem at hand. We're supposed to be finding the probability of product failure. Okay, so product failure can occur two ways. Product failure can occur, failure can occur if the chips that are part of this product were exposed to high levels of contamination, or the product could fail if the chips it is made of were not exposed to high levels of contamination. So all I'm going to do right now is write this out, both of these out, according to the multiplication rule. So the probability F and H, I'm going to write, I think, in a manner that more shows what's happening in this picture to the right. So what's the probability of failure given the chips were exposed to high levels of contamination times the probability, I'm even in this category where the chips were exposed to high levels of contamination, plus the probability of failure given the chips were not exposed times the probability I'm in the region where the chips were not exposed. And you can see it's more likely that I'm sitting in the region where the chips were not exposed. And if that's the case, there's a smaller probability of failure. If I am in the region where the chips were exposed to high levels of contamination, failure is more likely. So really all I'm doing here is taking a weighted average according to if the chips were manufactured under high levels of contamination or not high levels. Okay, so what we actually call this here, what I am doing right here, is the total probability rule. I'm just breaking up the probability of failure into the mutually exclusive ways that that failure can occur under H or H complement. Okay, let's go ahead and write these out now because we've already pretty much alluded to all the probabilities above. So probability of failure given chips were exposed to high levels of contamination is 10%, times the probability that we're even using chips that had that were exposed to high levels of contamination, which is 20% of those chips, plus probability of failure given not a high level of contamination. So that was rarer, right? We said 0.005 times the probability sitting in this region, chips not manufactured under high levels of contamination. So this is 0.8. If we multiply this out, this is going to be 0.02 plus 0.004, which is 0.024. This is the probability of product failure, which we came to by using the total probability rule, breaking up failure into the two mutually exclusive ways that could happen. So I hope this example made sense. We were manufacturing a product, and the product could either be made with chips that were exposed to high levels of contamination or not exposed to high levels of contamination. And that failure really spanned both regions. And the way we found total product failure was to weight failure according to if the chips were manufactured in which of these two regions, either high levels of contamination or not high levels of contamination. So in the end, we found the total probability of failure using the total probability rule. So sorry for this, and I hope this video is okay, and I hope that the total probability rule makes sense, and we'll talk again soon.